You're on.
Well, my project was an audio switching device, specifically from three sources. The reason why I decided to do this kind of project is because people with the older vehicles don't have integrated Bluetooth systems. And so the way you can do it is by changing your radio to an aftermarket unit, which costs over $100, and some people don't want to spend over $100 just to integrate their Bluetooth systems. Plus, when you do that and you have steering wheel controls, it's kind of complicated to then integrate those steering wheel controls with the radio. So basically, the system diagram, I've got person over here, in this case is me, has a phone. That phone will be connected to a 3.5 millimeter audio jack, standard audio jack. That audio jack will be sensed by the comparator, the microprocessor, which it'll automatically switch when there's a signal on that input, and it gets sent to the powered amplifier and thus to speakers, and there's me again listening to my phone call through the vehicle sound system. How this is done is with single pole, single throw switches. I requested from Analog Devices to see if I could get some samples on a quad bilateral switch. They're surface mount devices, and so depending on the size package you have or you get, it can be easy or annoying to try and mount those devices. The reason why I chose the newer devices versus the older ones is that the gate turn-on voltage is above 2 volts, so I can directly take the microprocessor to each individual switch and turn on the switch and close, so the signal passes through. And so, wiring concepts, the radio is over here, and in most every case when there isn't a phone call, the radio will just be sent to the powered amplifier and to the sound system. And then when there is a phone call on one of the audio jacks up here, the microprocessor will switch the corresponding switches for that particular audio jack, and then close all of these switches to the powered amplifier and open those. And then the other audio jack is for an auxiliary input, and so I can push a button on the board to then it'll kind of be like manual override, so that it'll switch to that input. And then when I'm done with a phone call on the main input that gets switched to, I'll push a button so that it will reset to the radio input. So vehicle schematics, what's kind of nice is that in my case is that all of the audio signals go through powered amplifier, and so I don't have to amplify my signal from my board. I just have to switch the signal to the powered amplifier. And so these two lines are this one is the left rear, right rear. This is ground, and then this one is the left front, and that one is the left rear, and this is the switched power for the powered amplifier. I'm going to utilize this wire to be able to turn on my board so that when the radio turns on, my board turns on. And then when the radio turns off, my board will turn off. And so by having these wires is just going straight to the amplifier, as I said before, it allows me to just switch the signals to the amplifier. This is just grounding to on these signal lines, so then there's a lot of excess noise that is in the vehicle wiring harness. This is my schematic for my board. These over here are the switches that'll switch between the two audio jacks. And so then on over here is the comparator input. And so the one of this pin over here is going to be connected to this pin over here as well. This resistor is so that the current doesn't get great enough that blows out the diodes that prevent the reverse polarity in the comparator input for the analog input. And so then power for the chips. So I didn't have a bunch of resistors on my board. I had to then connect the negative power. Well, from a vehicle, you have VSS, which you have 12 volts power. And so I utilized chip, which is the ICL 7662. It is a voltage converter that'll take an input supply and create a negative supply, biasing supply that can supply up to 0.2 milliamps. And so for these CMOS switches, that's fine to have 3 of them. They use microamps, so I can definitely use that as a biasing supply. These are those switches that I was talking about. And this is that transistor that is going to switch on my board. And so then this is the connector. I also requested a connector from Molex, and they were gracious enough to send me a sample. And that way then it's a small profile connector. It's really nice. This is the switch set for the radio, so that it'll just get switched through when there isn't any signal input or a user hasn't selected the input for the auxiliary. And so since I don't need all these to be individually controlled, I can just control them with one pin. And so I just tied them all together on the board and just controlling them with one pin from the micro. And the currents are so low that it'll be fine. This is that 7662. It just takes 2 10 microfarad capacitors. Pretty simple to wire up. Here's the board layout. This is board 2.0. Board 1.0 I had set up, and it wasn't quite going to work out exactly as I had hoped. And so I ripped it all up and redid it. I had to manually route all of the traces on this board because the auto router didn't quite exactly do what I wanted it to do. And so I made all the vias to be roughly 16 mils on the outer, so that then I could easily solder to them. Then these are those quad bilateral switches. And so they're placed in, all the ICs are placed in this certain fashion because the top of the board is V plus, or the 12 volts power. The bottom portion of the board is ground. And so by doing that, I eliminate the need for decoupling capacitors. And so, which reduces the amount of components that I have on my board, and potentially, increases the reliability of the device. The audio jack inputs, push buttons, all these red blocks here are just restriction regions when I was running the auto router, so that then I didn't have vias underneath my audio jack, so that then it didn't be a pain to solder a wire that's underneath that. And so then these are just the headers, obviously, and only needed 2 of the headers that are on the Freescale KL25Z microprocessor. And then obviously the connector over there and the transistor. So the end result is that there will potentially now be a product that can be used to essentially be somewhat of a Bluetooth system, but is a hardwired system. And so that way then the driver can have a phone call and not be as distracted not being on that phone call. Questions?
So you said it's going to be inexpensive. What would you have to price it at? What do you think the sales price would be?
Sales price, I would say, would be around $40 to $50. And the adapter harnesses, and so that then the harness, so that people don't have to splice into their vehicle harness, there would be an adapter harness, so that then all they have to do is just connect certain connectors and they're ready to go.
So did you need to do any sort of calculations, sort of talk about the choice of caps and some components on the schematic slide? Is there anything you had to calculate or?
The capacitors were they were given in the schematic of the 7662, and they gave a bunch of different wiring options for different uses of the device, and so I just chose the most common use was to create a negative supply, which they said use two 10 microfarad capacitors. The only thing that I really need to do some calculations for is for the resistor on the comparator input. The input to the comparator can't be too great because the reverse bias current cannot be greater than the specification in the data sheet. At this moment, I cannot recall what that specification was, but it was in the milliamp range. My signals are going to be ranging from 100 millivolts peak to potentially at max 350 millivolts peak, and so that way that resistor just limits the amount of current that goes into the input of the comparator, so the diodes don't get wiped out. The only other two things are the resistors for the gate on the transistor, and so since the gate it requires milliamps of current to run, and so to close and saturate the MOSFET switch, and so I chose a 1 k ohm resistor, and then it's a 10 k ohm ground. I could make it 100 k to ground. That's just there so that then when the radio turns off, the gate then discharges to ground, so that then it turns the switch off.